let's now learn about reactions of group 3. Reactions of group 3 cations. The cations present in group 3 are Al3 plus, Fe3 plus and Cr3 plus. Group reagent is NH4Cl ammonium chloride and NH4OH ammonium hydroxide. The nature of precipitate here you get metal hydroxide. Metal hydroxide. And remember, aluminum hydroxide is gelatinous white. Ferric hydroxide is reddish brown. And chromium hydroxide is green precipitate. Now, another important thing we are supposed to know is what is the role of ammonium chloride in the group reagent. Role of ammonium chloride. You know, ammonium hydroxide dissociates to give NH4 plus and OH minus. You know, this is a weak electrolyte, it is a weak base, therefore weak electrolyte, it produces low concentration of OH minus. Now, in the same solution, if you have ammonium chloride which will dissociate completely into NH4 plus and Cl minus, it exerts common ion effect that will further bring down the concentration of OH minus. So, ammonium chloride exerts common ion effect on ammonium hydroxide and helps in maintaining low concentration of OH minus, so that only aluminum, Fe and Cr precipitate out as their hydroxides. Other cations like cations of group 4, group 5 do not get precipitated as metal hydroxides because their Ksp values are reasonably high when compared to Ksps of these hydroxides. That is the role of ammonium chloride in the group reagent. Now, after this we will be talking about the separation of group 3 cations and then we will talk about reactions of each group 3 cation. Let us now look at separation of group 3 cations. You have salt solution. To this you are adding ammonium chloride and ammonium hydroxide mixture. This should be added before ammonium hydroxide because it should be available to exert common ion effect. Otherwise, if you add ammonium hydroxide first, there won't be any common ion effect initially and all other hydroxides may also get precipitated. Now, you get a precipitate. You get a precipitate and to this we add sodium hydroxide and hydrogen peroxide. And then filter it. The residue contains ferric hydroxide, it is unaffected, whereas the filtrate will have a mixture of NaAlO2 sodium metaaluminate and Na2CrO4 sodium chromate. This is then treated with lead acetate and filtered. The filtrate will have NaAlO2. This is then treated with ammonium chloride to recover aluminum hydroxide. Whereas here you will have PbCrO4. This is the residue, PbCrO4. Now, this is dissolved in dilute HCl to generate AlCl3, and it can be used for testing Al3+, and this is also dissolved in dilute HCl to generate FeCl3, and it is tested in solution. So, this is how we separate the three cations of group 3. First add ammonium chloride and ammonium hydroxide, you get a precipitate. This precipitate may contain all the three. The precipitate may contain aluminum hydroxide, it may have ferric hydroxide and CrOH taken thrice. All the three may be present. Then add sodium hydroxide in presence of hydrogen peroxide. Then what happens, sodium hydroxide will dissolve aluminum hydroxide, and it will oxidize, alkaline hydrogen peroxide will oxidize chromium +3 to +6 state. Then you add lead acetate to dissolve, to precipitate out lead chromate, and this remains as sodium meta-aluminate. It is then treated with ammonium chloride to give aluminum hydroxide. Whereas the ferric hydroxide residue formed in this step will be treated with HCl to give ferric chloride. This can be used for testing ferric. Well, under reactions of group 3, the first one we are going to discuss is reactions of Al3+. First we will talk about reactions of Al3+. Al3+, when the salt solution containing Al3+ is treated with ammonium hydroxide, you get a gelatinous white precipitate aluminum hydroxide. Gelatinous white precipitate. This is insoluble in excess of reagent. Next, Al3+, when it is treated with sodium hydroxide, you initially get aluminum hydroxide, a gelatinous white precipitate. This will dissolve in excess of sodium hydroxide. When you add excess of sodium hydroxide, it will dissolve as NaAlO2. Soluble sodium meta-aluminate is formed. Next reaction, salt solution containing Al3+ is treated with disodium hydrogen phosphate and get AlPO4, aluminum phosphate, which is a white colored substance. And then the reaction I am going to discuss now is a dry reaction. Aluminum salt, you will have to take salt as such, not salt solution. Add cobalt nitrate and heat it. So, when you heat aluminum salt, it decomposes to give aluminum oxide, which is an amphoteric oxide. And when you heat cobalt nitrate, it becomes cobalt oxide, which is a basic oxide. So, this amphoteric oxide and this is basic oxide, which is formed COO, cobalt oxide. So, acid base reaction takes place and you get COAlO2 taken twice. This is a blue pigment called as Thénard's blue. So, formation of a blue substance indicates it becomes a confirmation test for Al3+. Thénard's blue is formed. Cobalt meta-aluminate is Thénard's blue. Reactions of Cr3+. A salt solution containing Cr3+ is treated with ammonium hydroxide. You initially get CrOH taken thrice. It's a green colored precipitate, and if you add excess ammonium hydroxide, then a soluble complex CrNH3 taken 6 times 3+ is formed. It's a soluble complex. Cr3 plus when treated with alkaline hydrogen peroxide, you get Cr3 plus gets oxidized to Cr plus 6. So you get Na2 CrO4. This is a yellow colored solution. To this we add BaCl2, barium chloride. Then you get a yellow precipitate of barium chromate. So these are two important tests for chromium. So this becomes a confirmation test for chromium. Reactions of ferric. See, here we are going to talk about reactions of ferric. Keep this in mind that ferric is a very powerful oxidizing agent. So if you react it with some reducing substance, then redox reaction is expected to take place. Ferric may become ferrous. So you can have simple precipitation reactions of ferric. You can as well have redox reactions involving ferric. Let us discuss one by one reactions of ferric. Ferric reacts with ammonium hydroxide and you get a reddish brown precipitate of ferric hydroxide. Same thing happens with sodium hydroxide also, NaOH. And remember, in both the cases it is insoluble in excess of reagent. Insoluble in excess of reagent. C. Fe plus 3 on reaction with sodium hydrogen phosphate, it gives FePO4. This is a yellowish white precipitate. Fe3 plus KCN, potassium cyanide, it gives FeCN taken thrice. This is brown colored substance, and if you add excess KCN, you get FeCN6 3 minus, which is yellow colored solution. Ferricyanide is formed. E. Ferric, when it reacts with Ki, redox reaction takes place. Iodide is a good reducing agent, ferric is a good oxidizing agent. You get FeI2 plus I3 minus. This is responsible for brown solution. Fe3 plus ammonium sulfide, you get ferrous sulfide plus sulfur. This is a black precipitate, ferrous sulfide. There are some more reactions we'll do after this. So with both ammonium hydroxide and sodium hydroxide, you get a reddish brown precipitate, which is insoluble in excess of reagent. With sodium hydrogen phosphate, you get a yellowish precipitate of ferric phosphate. With KCN, you initially get a ferricyanide, which is brown colored, and excess of KCN will make it yellow colored complex substance, ferricyanide, hexacyanoferrate 3. On reaction with Ki, redox reaction takes place. Ferric becomes ferrous and I3 minus is formed, which gives brown coloration to the solution. And with ammonium sulfide, you get ferric reduced to ferrous sulfide and sulfur is formed. The color of ferrous sulfide is black, that dominates, and this anyhow is yellowish substance, but this will dominate and the solution appears black. Some more reactions of ferric. Ferric, when it reacts with KSCN, potassium thiocyanate, you get FeSCN taken thrice. This is blood red color. Ferric, when H2S gas is passed in ferric salt solution, you get ferric reduced to ferrous and get sulfur. So, by default, a solution of ferric salt will be acidic. So, under acidic conditions, if you pass H2S, you don't get a precipitate of ferrous sulfide, but you get a precipitate due to sulfur. So, sulfur atoms aggregate to form acid molecules. Acid molecules aggregate and form a colloidal solution, which appears bluish, and then ultimately when it precipitates out, it becomes white. Bluish white. The bluish white coloration is due to Tyndall effect. Tyndall effect is responsible for, because you get colloidal sulfur and that exhibits color due to Tyndall effect. Ferric on reaction with K4FeCN6, it will give ferric ferrocyanide, Fe4FeCN6 thrice. This is Prussian blue. Ferric ferrocyanide. Outside the coordination sphere you have +3, Fe +3, and inside you have Fe +2. So, it is ferric ferrocyanide, popularly known as Prussian blue. It is a blue colored substance.